Okay, so we're getting to 611, solving problems using similarity, and you should be able to solve mathematical problems involving similarity in two-dimensional figures. So this is going to be a lot of proportionalities, setting up proportionalities and solving for x. You might actually even see some distribution. We're going to dabble into a little bit of algebra here. So it's not going to be well, it's going to be a little bit fun. Maybe you know kind of similar to you solving problems using congruity, um, but instead of things equaling each other, there'll be things equaling each other and then time multiplying it by some type of multiple or proportionality, right? So uh, similar, but not quite exactly what you're used to. Okay, so here we have two triangles, right? So we have triangle CKV. It's my orange triangle. We just need to be as thick there. And we have triangle TNR, and that's my blue triangle. And they are similar. It says so right here. They are similar. And it tells me some of them are given right here. All right, so I'm going to move them so that we can just kind of, and you should do this too. I would say move them, but I would say relabel them. I'm just going to move them because it's easier for me to move them than it is to relabel. So TRN, you can move that to vertex R. That's 28 degrees. I'm going to do it like that's transparent, so it's not ugly. That's going to be 28 degrees. And vertex C is going to be this one right here. That's going to be that one right there. These are angles, remember, not line segments. Don't confuse the two. Okay, and then we have angle N. Angle N over here. Everything with it. Angle N over here is right that one. Okay, so let's deal with our angles first and kind of see if we can figure out all the angles here. Right, so we have similar shapes. So if you remember what we know about similar shapes, that the angles of the similar shapes are, and you remember they are equal to each other, right? So let's take a real quick selection of, I'll say K here. All right, I take K here, and like maybe I'll rotate it. I don't know if it's going to line up, right? Because the limitations of this program. Maybe I'll rotate right 90 degrees. And hey, it worked out, right? Look at that. That one, it lines up with N really well, right? We'll do that, right? So this one lines up with N. So I'm going to kind of annotate that. That's N's. This one's counterpart is N. Congruent counterpart, as I like to call them, is N. That means that this one's got to be congruent counterpart's got to be R. And this one's congruent counterpart is pretty obviously T. All right. So now I'm looking at, what do I know about the internal angles of a triangle? If you remember, the internal angles of a triangle, they all equal, the sum of them, if I add them all up, they're going to equal 180 degrees. So I'm going to make some marks here to help me identify what is congruent to what. So this is my single arc. I'm going to make that one my single arc. V and R is my single arc, right? Yeah, single arc. Make it a little better. So this is my single arc. This is my double arc, indicating that these two are, what did I call it earlier? Corresponding pairs. I call them, I don't remember what I call them over. I keep forgetting that. All right, so and this is my triple arc. 1, 2, 3. This is 8x plus 26. Go. So just 1, 2, 3, so I can read that better. All right, it's correlated pair, corresponding pair. Man, what did I call it earlier? I always forget that. Okay. All right. So anyway, I know that angle 1 plus a double angle plus a triple angle all equal 180 degrees. Right? So, and I'm lucky enough that, or I'm not really luck, I know that I only have one variable term in all these. That's x. That's cool. Right, so I'll start my equation like this. Right, it's going to be 28 degrees. It'll be 28 degrees. It'll be plus, my double angle is 12x. 12x plus, well, I guess technically it should be a red. 12x plus, or minus 8 actually. Minus 8. Minus 8. That should be blue. Is it attached to 8? Minus 8. Minus 8 plus 8x plus 8x because it's attached to the 8. Blue plus 26. That equals 180. That's constant. Right? So that is how that all works. So I'm going to add up the constants. 28 minus 8 plus 26 equals 46. 46 equals 180. 12 plus 8 is 20x. And then I'm going to go 20x equals 180 minus 46. So x equals 20x equals 134. And then x is going to be equal to some weird ugly number. 6.7. And as always, double check to make sure you did it right. So 12 times 6.7 minus 8 equals 72.4. And then you'll have 8 times 6.7 equals plus 26 equals 79.6. So they should all add up. So plus 72.4 plus 28 equals 180. So all that stuff adds up. All right. Moving on. It's different than what the book says. I wonder why the book says it's 8.5. I'm going to pause it and see what the book says. Why is my math right and the book's math is wrong? That's weird. Let's see what happens if we put 8.5 in there. 12 times 8.5, 85. 12 times 8.5, 2 minus 94. That doesn't look like 90. It doesn't look like 72.4 either, but okay. And then this one says it's 8 times 8.5. Eight. Doesn't make any sense at all the way they did that. Doesn't make any sense at all. Okay. All right. I don't know why the book says that. Because 94 plus 94. That doesn't make any sense. I think the book is wrong. Some better bench given. Huh. That's weird. All right. Anyway, so my math is right. Their math is wrong. I'm moving on. So now I have that these. Am I paused? Still rolling. Okay. Now I'm gonna switch over to green, and I'm gonna say that VR equals 8. I can write these ones down, I believe. VR V wait a second, what's this saying? VK, sorry, VK equals 8. I want to be green. VK equals 8. VK equals 8. That really bothers me. I'm gonna study that real closely after I submit this to see if I misread the example or something. But I don't think I did. And if I did, I need to submit a feedback report to that. Anyway. All right. So anyway, so VK is 8. CK is 5. Z plus 1.7. And then CV here is 5.4. 5.4. All right. And then our other side here, it is supposed to be proportional. Let me get rid of this data that is incorrect here. Right. This, I'm gonna go. Okay, so now we're gonna say that TR is 2y minus 1.25, and then RN is 10. TN is 5.25. Now we gotta solve for stuff here. Right, first, what's our ratio? What do we do? Do we know a good ratio here? That's what we need to figure out first. So do we have any of the line segments that don't have a variable? That's what we need to know first. So N and R, so NR, RN, and KV don't they are supposed to be similar, and they don't have a variable. T and V, or T and R, those has a variable in it, so we can't use that one. What about T and N? T and N also has a variable in it, so we can't use that one. So we have to use uh, N and R and K and V. These two line segments. We have to use this line segment to that line segment, and that's what we're gonna do to figure out what the proportionality is. So, because all these line segments, if if they're similar, and it says that it is similar, the two triangles are similar, it tells us that, so that we know that this line segment and this line segment that are paired line segments, they are what is that word I used earlier? Anyway, these are line segments that are correlating. They are indeed similar. So this one and this one. All right, R and T, yep. And then we got T and N, T and N. This one is number 3. This one is number 3. All right, so we got to set up a ratio here. What's our ratio? I'm gonna go orange. I'm gonna go orange to purple. How's it gonna be my ratio the way I'm gonna set it up? Or is that blue? I don't know. Orange to blue. So my orange is gonna be on top. My blue is gonna be on the bottom. All right, and it's gonna be like it's gonna be big or small to big. All right, but I'm gonna use color codes. So it's gonna be 8/10. Right, so equals 8 over 10, right? 8 over 10, or 4/5. That's what I decided to do. I did like 5 over 4. Okay. All right. So now, if I want to solve for any one of these, I just need to take that ratio there and multiply it by whichever one I want to be defined, right? So if I want to find this, right, and I know that I'm going from the big one to the small one, right? Right, I'm just going to be 4/5. This was little over big, right, equals little, right, which is this one was my 4/5, right? Oh, I need to do. It's going to be equal to it's going to be equal to, I'm going to take the side that I want. We'll say I'm going to solve for RT, right? RT is going to be on the big one, right? So that's going to be, this is my blue one right here on the bottom, right? This is my blue. My 5, right? Number 5 was on the bottom. 4/5, right? So it's going to be 2y minus 1.25. And then what is its corresponding pair, right? RT is paired up with 5.4 on the other side, 5.4, 5.4 on this side, right? RT, RT. So now I just cross multiply. I'm gonna have to distribute, right? Remember, this is something like, this is like this, right? So what's 4 times 2y? That's gonna be 8y minus 4 times 1.25 is 5 equals, I'm gonna be like, hey, what's 5 times 5.4? That's 27 equals 27. All right, I'm gonna add 27 to that. So I'm gonna add 5 to 27 to clear from the other side. So add 5 to both sides. And get rid of that. 8y equals 32. And I think y equals, I'm not sure about that. Round 4. So y is going to equal 4 here. That's kind of neat. Okay, and then we'll do the same thing. We'll take some more room here. I'm going to take this and scooch it over right here. Make some room right here. Still going to use this 4/5. I got this. I'm using my 4. Fifths. All right, that's my ratio from 4/5. And it's going to be equals to, what do I need? I need to solve for z. That's from my orange side. So it's going to be on my orange side. 5z plus 1.7. So it's on the top. All right, and then what's its corresponding line segment on this side? That's my triple one. It's going to be equal to 5.2 down here. Oops, that's supposed to be a different color. That's 5.25 actually, 5.25. Right, and I gotta distribute again this guy. Right, so I'm gonna cross multiply. I'm gonna make this 4 times 5.25. That's like 21, I think. That in my brain. 5 times, no, that's wrong. Go back. Get that wrong. 4 times 5.5. 5.25. I did that right in my brain. 21 equals 25z. 25z because 5 times 5z is 25z plus 5 times 1.7. That's 8.5. 8.5. That's not going to be a cool number. All right, so I need to subtract 8.5 from both sides. I added negative 8.5 to that side. Same thing as subtracting 8.5. So let's see. I'm gonna add 8.5. The word floppy button. This is, oh man. Plus 21 plus 8.5 negative. That's 12.5. Oh, it's going to be a half. And I'm going to divide both sides by 25. See that divided by 25 is a half. Z equals 1/2. That's pretty smooth. Okay, so now that I have Z and I have Y, here's my Z value. I'll block it off in red. Z and Y. Now I can plug and chug. 2 times Y is 4, so it's 8. 8 minus 1.25. 8 minus 1.25 is 6.75. And this is going to be 6 point, let me make that 6.75. Cool. And then that's 2.5. Because half of 5 is 2.5. 5 times 0.5. That's my Z value, right? And then plus 1.7. That's going to be 4.2. 4.2. That was fun. Wasn't that fun? That was like a math puzzle. Math puzzles are cool. I thought that was fun. Cool. All right, so let's go over to this one. How long have I been going? I was recording that, right? Yeah, I think so. Recording that one. That's good. Okay, now we got this one right here. I got KVR, this little guy, this red one, this little guy. And I got KCN, KVR and KCN. Little guy, big guy. Big guy's blue. And they are similar. It says so right here. And then we got KV, or sorry, RV. This guy is 4.6. Should be red though, because it's part of the little guy. 4.6. KR is also part of the little guy. It's 3. Oh, got a big chin. 3. This is 5x minus 11. Minus 11. NC is 11.5. And KC is 3x plus 1. 3x plus 1. All right, and let's solve this one. Okay, so let's figure out what our proportionality is. What would you do? What would you do? We'll do big triangle. Okay. I'll pause it for a second. All right, so I'm going to show a series of steps, and I'm going to make an intentional mistake. I want you guys to see if you can catch it. And then I'll go back and I'll show you where the mistake is. and then I'll show you how to correct that mistake. Okay, so first thing I'm going to do is zoom in and give us a little bit more room. Maybe get it click out a little bit. That's, oh well. All right, so maybe, okay, well, let me get this a little bit better. Oh well. Okay, so first thing I want to do is determine what the proportionality is. All right, I'm going to go big over little this time. So my big over little is going to be this triangle length, NC over NC over RV, because these are going to be, these are proportional triangles. My big one is the big blue one, big blue one right here, right? And this little red one right here. So these are the RV and NC are my proportional line segments. All right, so I'm going to go 11.5. So I'm going to do NC divided by RV. I'm going to set that equal to, that's a C. Yep, C. I'm going to set that equal to 11.5 divided by 4.6. That's going to give me an E proportion. Now proportion is going to be 11.5 divided by 4.6. And that's 2.5. That's nice. That's a nice round number. That's 2.5. That means that this big triangle is 2.5 times bigger than the small triangle. So I want to solve for x here. Okay, so in order to solve for x, I'm going to set up my equation here. And I'm going to say that 2.5 times my length of 5x minus 11 is going to be equal to my longer triangle one of 3x plus 1. All right, so 2 of these is going to be equal to the long one of that. All right, and then I will just solve for x here. I'll distribute 2.5 into that's going to be 2.5 times 5, 2.5 times 5 equals 12.5 minus 11 equals 1.5. Oh wait, I did that all wrong. Hold on, let me back that up. Control Z. Oh, so plus 1. So 2.5 times 5 is 11. Yeah, 11x. Minus 11. Here we go. Check that. 2.5 times 5 equals 12. 12 x minus 11. Yeah, check. 2.5 times 5x is 12.5x equals 3x plus 1. All right. Now we'll go variables left, constants right. 12.5x minus 3 is 9.5x. That's going to be 2 be equal to, and then that'll be equal to 12 x will be equal to 12 divided by 9.5. 1.263 for x. Okay, so now we'll put 1.263 into here. 5 times 1.263. Multiply that by 5. And subtract it with 11 from that. And that means that KV should equal negative 4.68. Negative 4.68. Okay, so obviously, if that's not obviously wrong to you, then do a dummy check. I mean, how can a line segment have a negative value? Right? It's obviously not a negative value. Okay. So where did I go wrong? Pause it and think about it. Okay, so where, if you haven't figured it out, is it's when I set up my proportion right here. This means that 2.5 of these equals this. And that is not necessarily a true statement. Okay, if I want to make this correct, this is how I'm going to have to set this up. So I'm going to have to set it up like this. Okay, I'm going to go and I'm going to say, let me change this into a fraction, right? 2.5 is 5 halves. So my big one, 5 halves. Let me do it like this. So 5. Okay. All right. So, and then from here, it's going to be equal to, and now you have to go and look at you have to go and you got to look at the respective lengths. Okay, it's NC here. Oh, sorry. The respective lengths I'm comparing are KC, which is the long one. So this will be 3x plus 11, right? And then I'm going to do 5x minus, sorry, this would be 3x plus 1. 3x plus 1. Okay. Then I'm going to do 5x minus 11. Minus 11. That is the proper ratio for this long one to the little one. Now I'll cross multiply. So to make sure I distribute properly. Right? So I'll do I also when I did my math here, I didn't multiply this properly. And there you go. Okay. So when I multiply here, I go 5 times 5 is 25. 5 times 11, 25x. 5 times 11 is 55x. Okay. And that's going to equal 6x plus 2. So that is the proper calculation. Well, it's not 55x, it's just 55. Something like that. Okay. So now I'll do, I'll take my variables and I'll keep my variables positive. So that's going to be 19. It's going to be 19x. 19x equals, and then I'm going to take this and I'm going to put it on the other side. 19x is going to be equal to 57, and x will be equal to 57 divided by 19. 57 divided by 19, which equals 3. X equals 3. All right, so I go here, I go 15 times, I go 3 times 3 times 15, which is 45. That's not right. 3 times 5, which is 15. This is now 15. It is minus 11. Minus 11. And now this is 4. So this makes a lot more sense now. Okay, and now if I did, this is 4, if x is 5, and that means that this is, oh sorry, if x is 3, it means that this is 9. That's 9, so that means that this whole value here is 10. This whole value here is 10. So that makes that a lot of sense too. And that means that this value here is 6. Pretty cool. All right. So hopefully this all makes sense to you. Make sure you're distributing right. Okay, even if we didn't distribute this right, let's see what would have happened if I would have distributed this right. So this would have been 12.5x minus 2.5 times 11, that would be 27 minus 27.5. It would have been, then it would have been 12.5x equals 3x plus 13 plus 12. And it still would have been wrong. It would have been, then it would have been 9.5x. Oh, no, it's not right. 12 would have been 27. It would have been 7.5. It would have been 28.5. 28.5. So it would have been 12x. 12.5x. 20.5x, 31.5, 30 equals 31.5. 5 divided by 12. Wouldn't have been right. I don't think. Let's see. 12.5x minus 27.5. 7.5 plus 3 is 30.5. Not one. Yeah, it wouldn't have been right. It wouldn't have been right either way. It wouldn't have been negative though. Would not have been negative. Yep. So two mistakes. Two mistakes here. Did not distribute. Right. That was not intentional, but also didn't set it up. Did not set it up correctly here either. Right. They did not have this. If I had multiplied. Yeah. So anyway, I hope this works out for you guys. If you understand all this stuff. Make sure you're setting up your ratios correctly and cross multiplying properly. Okay. You guys have a great day.